Okay, the inverted scale on here, if I put this on a 1, put this on a 1.2, if I move this over here, there's a 1.2. So the inverted scale is basically the regular C scale that goes clockwise this way. It's the same scale except it runs counterclockwise. So this 1.1 is the same angular position from here to here as it is the 1 to here. The 1.2 is the same distance from here to here. So that's used to give reciprocals. So if I put this over here in a 1.25 reciprocal, let's say this was 1/8 of an inch, there's an 8. Also, you can go look over here that there's an 8 and there's a 1.25. Now on these scales, they put numbers that you use a lot on the scales. So there's a 4/pi. They've got little numbered in there. If you go through and you look at, here's pi. Here's on the C scale 3.14. There's a little pi symbol. So if you have to multiply something real quick, there it is. So if you're going to go multiply, say, pi times 3, of course it's close to 9. You can put this on the 1. Put that on the pi. Rotate this all the way around. There's the answer, 9.4. Now some of these have actually some other symbols on there which are kind of cryptic. This one seems not to have too much on it, but the pi/4, a lot of times you use for calculations for diameters and things, for area. In any given scale on here, you have to go ahead and look at to figure out what the intermediate numbers are, which means if this is 1, case this is 2, what you do is if you grab a different slide rule or whatever, you got to kind of get a feel for where the scales are. So if this is 1, this is 2, 1.5, of course there's 1.1. Then you have to see how it's subdivided. There's 1 point, let's go look to make this simple. There's 1.11. So if you put the cursor right here, this is 1.105. So you're getting like almost 4 decimal places accuracy down in here. But if you get over here where you've run the scale all around, you've got 0.99, and then these little tick marks here are 0.992994. So the third decimal place, you can put it between 2 and kind of estimate it, but you really have 2 decimal places, and the third is got within 2 digits. Now if you got a shorter slide rule, or you're using down here in these other scales, you've got even less. So in a slide rule, normally you want a longer slide rule, gives you a little bit more accuracy. A lot of times what you're using these for, you're just trying to get something in the ballpark, so it doesn't really make that much difference. Like on here, this thing looking for the square root of 2 is 208 volts. So the nominal voltage in your house probably varies 5 or 6% all the times, varying all over the place a little bit during the day, depending what the loads are. And then even if you measure the voltage, AC voltage, a normal AC voltmeter, and AC is usually only accurate to 1% anyways. So this calculation I did of 120 times the square root of 3 over here is 208 volts. You got it within a volt or so. So that's good enough for a lot of work, because you don't know all the other parameters, what you're trying to do. In using one of these things, you kind of get used to one rule, and if you've used one a lot, it gets to be real quick to use. If you grab somebody else's slide rule or one you haven't seen in a long time, it can be really confusing. So normally if I haven't used one in a long time, I have to go through and make sure I know what the heck I'm doing on one of these and how to read it. It seems kind of like a weird funky device, but once you use one, you can get fairly quick with it. I mean, if you got an RPN calculator, you can, bang out an equation really quick. But these things are still kind of funky things to use, and they're kind of cool.